Welcome to myprojectbazaar.com. Now we can going to discuss about the project autonomous power control management between standalone DC microgrids. Now we can going to discuss about the abstract of our project. First we can see about the DC microgrids. DC microgrids are nothing but a small generation scale of power. We can transmit the one of the domestic side receiving part. So we can some in our base paper systems when you use the autonomous DC microgrids and use the efficient process to apply the renewable system. So improve our gaining the popularity, and the remote control system also use that. Overall charging and discharging scenarios of the batteries, so we can use the bidirectional converters. This is a mainly effective process of the bidirectional converter of the switching pulse, also given control management of power grids. So we can how we can load set to the different type of energy management system in the microgrids. So proposed system is simple and reliable of bus voltage, utilize the shifting nodes without having dedicated communication lines. The power control and management technique has been bus signal method is governed to the storages and the loads as achieve the effective coordination of the energy management between the microgrids. Now we can going to discuss about the flow diagram of our project. First we can see about the solar panel. The solar panel integrated with the maximum power point tracking algorithm. We can use that. This is passed to the DC to DC converter, some conversion process to improve our power. Left side we can see the one of the system is on high tension side, another is on low tension side. So this is combined to the inner of the converter, single phase converter. We can use the switching pulse of sinusoidal pulse with modulation. So first we can see the solar panel. The solar panel we use of the input irradiance level is very high, is passed to the DC to DC boost converter. We boost and improve the power. We can use to the converter. The converter can control the entire loads. We can how we can get the load will identify the load demands response. We can use the process. The DC to DC converter pass the signal is pass the converter is another thing is load is very high. The solar panel is not given that power, is not efficient. The battery energy, so battery storage system can use that bidirectionally act as on load response demands. So is similar that right side also. This is a very effective controller of the process. So given the switching pulse, sinusoidal pulse with modulation. So our system is an entirely safe and sufficient work for solar panel with microgrids. Now we can going to discuss about the running procedure of our project. The proposed system implementation done in MATLAB version 2013A. First open the MATLAB file window and create a new model file. After the creating the elements as per the circuit diagram, the output waveform will be corresponding scopes are connected in the circuit diagram. First I can show that the circuit diagram of the project. This is our circuit diagram, entire circuit diagram of the project. This is on high tension side, low tension side, similar that as per flow diagram process. Next I can show these corresponding scopes are connected the different types of subsystem blocks. I will show the results. This is an solar panel one. Big solar panel one means a high tension side is an very huge amount of power generation in IV PV characteristics. Sun power voltage y axis is an power, x axis is power voltage. So we can a huge amount of power generate the solar panel. Next we can see the solar panel IV characteristics. It is an IV characteristics of solar panel 1. Again we can see the solar panel 2 PV characteristics. This is solar panel 2 PV characteristics. Because of this is a strip amount of step and increase the gradually. This is nothing but we can irradiance levels, some boost up levels you can achieve that. So output will be slightly changed. This is an PV characteristics. Next we can see the IV characteristics of the solar panel. Is similar that we can solar panel, but amplitude ranges and some difference. Next we can see the battery 1 output. This entire battery output result is on some drop and increase the charge of the solar panel. This is a state of charge, and the voltage of the battery is fully constant to whatever 110 below. We can steady state will the process. Exactly, we can see that 107 we can constantly maintain the voltage. Next we can see the battery of solar, another microgrid side too. This is our step down, and similar that is 54 state of charge will decreases after it will get to charge. So this one voltage also remains constant. We send 26 voltage, it's constant to send the battery. Next we can show the load on so autonomous microgrids, and first high tension side is a very huge amount of load is needed. So our solar power generation is very high also, so we can consume the power of the load is an waveform. Next we can see the load 2 compared to autonomous microgrid 1, and this is an 2 load, because of we can see the 3000 something amplitude range of previous ones. This is an something for 250 remains as an peak over voltage, so that this is a difference for that consumed the voltage, because our system is very efficient to given the switching pulse of the converter. I will show the switching pulse. This is a switching pulse of our converter levels. So it's an switch 1, switch 2, and switch 3, switch 4. Is a randomly sequence on and off the switches. This one system is systematically efficient, and the system is very balanced to the load shedding of the process.